Good morning, dear students. In the last class, we had already discussed about the discovery of electrons. Now today, we will learn how protons were discovered. See students, I told you in the last class that an atom, this is electrically, okay, any atom, it can be, that is basically electrically neutral. So, once an atom is electrically neutral, so what happens over here is that because of the electrical neutrality, the number of electrons and protons should be same so that they cancel each other and make the atom electrically neutral. Now the question comes up over here, how protons were being discovered. See, protons were being discovered in the similar manner like the electrons. Only a small change was there in the setup. Now let's see what the change was there in the setup. Okay, they have taken this as a anode over here. Okay, we have taken this as the anode, that is, this is the positive terminal, and we have this as a cathode over here, but the cathode is made in a different manner. We have made the cathode, okay, this is a cathode, we call it to be as a perforated. Remember the word perforated. Now why is it called as perforated? I am telling it to you. The reason is this cathode is having small holes inside it. Okay, the cathode is containing small holes inside it. That is why we are calling it to be as a perforated cathode. Now see what happens. Goldstein. Okay, Goldstein, while he was studying further with the same Crookes apparatus, he found that some of the rays, they are traveling in a straight direction towards this side, and at the same time some of the rays are moving in the backward direction, and a zinc sulfide screen is present over here. Okay, you have a zinc sulfide screen present over here. Over the zinc sulfide screen, fluorescent is seen. Okay, fluorescent is seen. The phenomenon of fluorescence is being seen on the zinc sulfide screen. So Goldstein was very much amazed about it as to what might have happened or for what reason the zinc sulfide screen which is present over here is giving this kind of fluorescence. Later on, studying the properties, he named these rays as canal rays. Remember the word, he named these rays as canal rays because they are passing out through these holes which he had considered to be as canals. Okay, that is why he named these as canal rays. Now see, to move on to the next term over here, that is, this is how the protons were being discovered, which were previously known as canal rays. Now to study the properties of the proton, how to analyze the properties of the proton. Then Goldstein, he performed certain experiment. What he did was, he applied the electric field over here. On applying electric field, he found that these canal rays, they got bent. Okay, they bend towards the negative electric plate. Okay, they showed bending towards the negative electric plate. Now once these canal rays, they showed bending towards the negative electric plate. So what happens over here is that because of this negative bending, in the last class I told you that opposite charges attract each other, similar charges, they repel each other. So since these canal rays were attracted towards the negative plate, that means the canal rays are actually positively charged. isn't it? The canal rays, they are actually positively charged. That is why, okay, for this particular reason, the canal rays got attracted towards the negative electric plate. So, Goldstein characterized that the protons are actually positively charged particles. Okay, is it clear to you? Next, what comes up over here is that the protons, they will always travel in straight line. You can see they are always traveling in the straight line. They are not traveling in the zigzag pattern, nor they are bending like this. No sort of movement like this. They will always travel in straight lines like this. Okay, is it clear to you? So this is how we analyze the properties of the proton. And protons, they are characterized by having a unit positive charge. Okay, we characterize the protons by having unit positive charge. And what is the magnitude? The magnitude is known to you. The magnitude is plus 1.602 into 10 to the power minus 19 coulomb. Okay, for electron you saw the same magnitude, only with the difference it was minus over here. For proton also we have the same magnitude, only the difference is that this will be plus over here because we are representing it for a proton. This is the magnitude. But in general we write the charge of a proton to be as plus 1, and for electron we write it to be as minus 1. So is it clear to you, children? So this is how electrons and protons were discovered. Now, once these electrons and protons were discovered, so Sir J.J. Thomson, he proposed the structure of an atom which we call it to be as a plum pudding model. Okay, we call it to be as a plum pudding model. Okay, or plum pudding model or watermelon model. Okay, we call it to be as watermelon model also. This model was actually proposed by Sir J.J. Thomson. Okay, this model was actually proposed by Sir J.J. Thomson. Now, the moment he proposed the model, so what he said in this particular model, he said that an atom is a complete spherical structure like this. Okay, an atom, it has got a complete spherical structure like this, and the electrons are all scattered inside. Okay, the electrons, they are all scattered inside it. Like in watermelon, you have seen the seeds of the watermelon, they are all scattered inside the watermelon. So in the similar manner, the electrons are all scattered around inside over here. So that is why this model was called as the watermelon model or the plum pudding model. Okay, at the time of preparing pudding, if you use plums over there, so the plums, they all remain scattered inside the pudding. So in the similar manner, Sir J.J. Thomson named this model like this. But this model which was proposed by Sir J.J. Thomson could not explain the properties of the atom very well. That is why this entire model which was proposed by Sir J.J. Thomson was completely discarded. Now, many years after that, another scientist named as Rutherford, okay, his name was Rutherford, he came to work in this field. Now, before Rutherford could propose anything, he decided to carry out an experiment. For this experiment, he chose gold foil. Okay, for doing this experiment, he took the help of gold foil. Now, why only gold foil? He could have used aluminium foil, he could have used zinc, he could have used copper, he could have used some other metal for this purpose. Why did he choose gold only for this purpose? The reason is very clear. The thing is, Rutherford actually wanted a very thin sheet. Okay, Rutherford actually wanted for his experiment very thin sheet like a paper, which is possible only with the help of gold, because gold has maximum malleable nature. Okay, gold has got maximum malleable nature. Because of this maximum malleable nature, gold foil was used by Rutherford. Is it clear to you? Okay, now let us move on to the experiment that Rutherford has done. We call this to be as alpha particle. Okay, we name the experiment to be as alpha particle scattering. Okay, alpha particle scattering experiment. Now, to move forward with this alpha particle scattering experiment given by Rutherford, see, what he did was he has taken a gold foil. Okay, consider this as a sheet of gold. Alright, now this sheet of gold, it has got the nucleus of the gold or the atom of the gold. It is there. Take for example, this is one atom of gold. More atoms are there. Okay, many more atoms are there, but we have considered only a single atom. This is suppose the nucleus. Okay, and this is the atom of the gold. Now, what he did was he used alpha particle. Now, alpha particle actually means helium molecule. Alpha particle actually means he has used helium molecule over there. Okay, now this helium, once this is bombarded to this particular nuclei over here, what are the changes that are going to take place? He saw most of the alpha rays, they passed out over this space very clearly, very neat and clean. They got passed out through the entire foil. Okay, most of the alpha rays. Some of the alpha rays, okay, some of the alpha rays got deflected into, okay, some of the alpha rays, they got deflected into different directions. Some of the alpha rays, remember the word very carefully, and very few of the alpha rays, they got rotated through 180 degree. Very few of the alpha rays, they got rotated through 180 degree. So this was the idea of the experiment which was given by Sir Rutherford. Now what happened? We need to conclude the findings of the experiment. We need to find a conclusion as to what has happened or what has taken place inside this gold foil or inside the gold nuclei, isn't it? So in order to classify that, he said that since most of the rays, they passed out of the gold foil, that means most of the space inside is empty. Okay, most of the space inside an atom is empty. This is the first classification. Okay, this one was the first classification which was found out by Sir Rutherford, that is, most of the space inside an atom is empty. What was the second finding that was categorized over here? The second finding was like this. Okay, the second finding was like this, that most of the particles, that is most of the alpha rays, since they got deflected, okay, some of the alpha rays, they got deflected, as a result of which what happened is that the alpha rays might have stuck something. Okay, the alpha rays might have an obstruction. Obstruction in what form? Obstruction in what form? Obstruction in the form of a nuclei. Okay, obstruction in what form? Obstruction in the form of a nuclei. They might have hit a nuclei and then they got deflected into different directions. Is it clear to you? And the third point that comes up over here is that very few of the alpha rays, they got rotated through 180 degree. What is the reason behind it? The reason is most of the space, since it is empty, so they passed away. Some of them, they struck against the sides of the nucleus, that is why they got deflected into different direction, and very few of them might have hit at the center. Okay, might have hit at the center of nuclei. Okay, they might have hit at the center of the nuclei, as a result of which, or because of which, the rays got deflected through 180 degree. Now see children, all these findings were from Rutherfords alpha particle scattering experiment. Okay, we got all these findings from Rutherfords alpha particle scattering experiment. Now, this alpha particle scattering experiment, it gives us certain idea. The very first idea is that an atom overall, it is having a empty space, that is lot of empty space is present inside an atom. Okay, now see, the nucleus will occupy only a very small space. Okay, the nucleus will occupy only a very small space. This is an atom, this is the nucleus. Okay, now this nucleus of an atom, this will occupy very small space, that is why the few of the rays got deflected into different direction and very few of them, they got rotated through 180 degree. Now, so most of the space is empty as it is seen, so this part is correct. Then the nucleus, that part is also correct, it is occupying small space. The electrons, they are moving in the fixed path, okay, which we call them to be as orbits. Okay, according to him, he said that electrons are moving in the fixed path, that we call them to be as orbits. Okay, electrons are moving in this fixed path, which we are calling them to be as orbit. Now, apart from this, that they are moving from orbit, they are passing through the orbits, we have protons and neutrons. Where are they present? They are present inside the nucleus. Okay, protons and neutrons, they are present inside the nucleus. Now, all these things were actually established by Rutherford, but there is a drawback associated with it. And what is the drawback? Look very carefully. The drawback is a very, very serious drawback. Okay, and that needs to be eliminated. Okay, drawback. And what that drawback is actually, the drawback is a very serious kind of drawback. Actually, what happens normally in case of any charged particle, once it rotates in a space very fast, so what happens over here is that according to the theories given by Maxwell and the dynamics theory, it says that a particle, once it is rotating continuously, this will lose its energy and will come to an end. Okay, it will gradually, it will lose its energy, and on losing energy, it will come to an end. So if that is the case, then the same thing would have been applied to the atoms also, isn't it? Then atoms, what happened? The electrons, they are rotating, then at the time of rotating, they should also lose their energy and they should also come to the end. This serious drawback, that means the atoms will be unstable. According to Rutherford's theory, atoms should be unstable, but that is not the case. So, how to rectify this drawback? I'll teach you the thing in the next class with the theories given by Niels Bohr. Till then, children, study the portions of the Rutherford structure, study the alpha particle scattering experiment. Till then, stay safe and goodbye.